Good afternoon, everybody, and welcome to another Geo-Institute live stream. If you are of keen mind and spirit, viewers, and I think you are, you will have looked at your calendar and you will know that today is October 1st, the month that we at the Geo-Institute like to refer to as Rocktober. We hope that you will be with us for all the things that we bring you this month, and we're kicking that off today. We've got this live stream with our friends from BoreDM. The brand new issue of GeoStrata has hit the streets on geostructural engineering. We hope you enjoy it. My name is Brad Keeler. I'm the director of the Geo-Institute, and we are thrilled to have you with us this afternoon as I won't say consummate our relationship with, but now those words have left my mouth, so it happened anyway, with our friends from BoreDM who are going to talk to you, at least the way we've been pitching it, is about the future of geotechnical data management. This is going to be a great one. We have an amazing audience for you today. If you don't know anything about the Geo-Institute, after you watch this afternoon, head over to geoinstitute.org, and there you will find out many facts about us, such as that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and we're all going to do our best to deliver on that, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. The final reminders from me is that today, of course, you renew your membership as you interact with us on the website. It is a great time to make your contribution to Geo-Institute student programs. 100% of your donation goes to student programs, and 100% is tax deductible. Very soon, we're going to have Ralph Peck bobbleheads, not unlike the Carl Terzaghi one I hold in my hand. And that leads us to your final reminder that tomorrow is Terzaghi Day. Of course, Carl Terzaghi's birthday in 1882. We celebrate this every year with a great live stream in the afternoon. We put up the Terzaghi tree, decorate it with all the Terzaghi ornaments, make stratified food, and do a whole bunch of other stuff that people in the rest of the world would think is very strange. But we have a good time with it, and we hope you will too. Now, all of that is out of the way, and here to be the host with probably more than the most today from Schnabel Engineering and from the Geo-Institute's DIGS effort, it is past president Alan Cadden. Alan, you're in charge now.
Thank you, Brad, and welcome to your lunchtime BoreDM session. So, hey, I met Lewis a couple years ago at a GI event, right when he was pretty much kicking off the software development and implementation of BoreDM, and it's been a pleasure to see him each year. And it really was a pleasure last year when he came back after first hearing about DIGS and revealed that he had implemented DIGS into the software. So he was one of the leaders in rolling this out. For those of you who don't know DIGS, it's data interchange for geotechnical and geo-environmental engineers, or experts, I think. And thanks to the GI and the GI Special Project Committee funds, we've had great success over the last few years at implementation with many different vendors. We've implemented a couple different forms of grouting, expanded construction implementation for pile driving, lab testing. GeoComp has worked with us closely through one of these efforts to implement it in their lab work. PDI has done great things with implementing it into the analysis side with GRL wheat. So that's all getting rolled out, and there's a lot going on with in-situ testing and MWD. So it's an exciting time with DIGS, and we're happy to see everybody starting to find a way to integrate it into their workflows. So with that, that's my shameless plug on the DIGS side of things for GI and for the industry. So if you are interested and want to hear more, we have a meeting first Friday of every month at 10:30 a.m. Eastern. Please shoot me an email, and I will get you on the invite list. Now, without further ado, I'll read a little intro here for Lewis. BoreDM is becoming the modern standard for geotechnical and environmental subsurface data management. This has been created by a team of software developers with input from hundreds of engineers And BoreDM has now been selected by over a dozen U.S. state departments of transportation and is leading firms across the United States, Australia, and Canada. So they're spreading their wings quickly there. BoreDM started in 2022, as I mentioned. Lewis did that as he was finishing up his work at Princeton, I believe, if that's correct. He was working with some software developers. He's a software developer by training. He encountered some challenges with Gint that we've all run into over the years as he was working with a tunneling company, and decided that it was time for something better. So he became curious, started cold calling engineers, figuring out what really needed to be done, and ultimately challenged himself to build something better. Lewis and the BoreDM team have consulted with engineers across the globe to create a product that is saving engineers and companies time and money. And I'm looking forward to hearing an update on how Lewis's team has tackled some of these challenges, and in particular, their integration of the dig schema. So welcome, Lewis.
Awesome. Thank you, Alan. And thanks, Brad, for hosting. First of all, both BoreDM and this entire industry, I think, owe a huge debt of gratitude to both Alan and the GI for what they've done with digs and pushing for a world where we can have a standard data interchange in this industry. So I know probably for most of you, it hasn't quite infiltrated your workflows or made its way into some of the tools you're using, but I'm really hopeful that it will in the near future. And if it does, a lot of that has to do with Alan and it's made possible by the GI. So and that's only one of the many things Alan has contributed to this space, but wanted to call that out. Okay, this presentation is about digs among many other things. The overall topic is this kind of concept of, well, people keep talking about model-based deliverables, people keep talking about 3D models and all this stuff, and what's going to happen to PDF boring logs? What about those things? And what does that mean for data management and how my workflows need to change, and where is all this stuff going? So those are the questions that I want to answer in this presentation. I obviously do represent a software company, and so our logo will be in various places, but by nature, I'm a horrific salesperson. I am a much better nerd, and I enjoy talking about data management. So this is going to be really just about data management and not so much about our product. I will, okay, I'll leave it at that for the intro. I think maybe the only other thing I'll say is, Alan introduced me, mentioned my backgrounds in software. I got into the space, I was working for a tunneling company, had to use Gint. And if you had told me, 4 years ago that I'd end up spending my weekends in coffee shops reading ASTM documentation for various laboratory tests, probably would not have believed you, or I would have been a little bit surprised. But I absolutely love solving the problem of data management for geotechnical engineering. It takes a lot of creativity. It takes a serious understanding of the underlying processes that are taking place when we're doing lab testing or when we're doing field testing or drilling or whatever it might be. And there's also so much innovation that's going on in the field. I don't know how many folks have encountered monitoring while drilling, which is kind of a new set of tools that are available. A lot of our DOT clients are starting to use that. And I got an email today that our first MWD file came into the BoreDM database, which is really exciting. So it's all sorts of new technologies. I'm really excited to be here and excited for the presentation. So with that, I will share my screen. Got some slides, which is a little bit out of character for me. I don't often do slides, but there's some good stuff to share here. And then, and actually, let me take it out of full screen. I think it doesn't want to share that. And then we can dive in. So let me do that real quick. Okay. Sorry about that. I had it in full screen. I thought I could share that window, but I couldn't. There we go. Okay, so I'm just going to share it from this preview window. I think that's all right. This is the most BoreDM you'll see in this presentation, just the intro slide. And by the way, if anyone can't see my screen, just let me know. Okay, so we're going to start off. What is a model? Which is probably a very simple question, but I think it's worth zooming out and thinking about this a little bit. So I think the defining characteristics of a model are that they're visual representations of data. They oftentimes visual. They don't always have to be visual, but oftentimes visual representations of data. Typically, models intentionally omit some of the available data. So if we take the most relevant example for us, which is a boring log, you might choose not to show all of your laboratory testing data on a particular log. You might say only this data is applicable or is relevant. So oftentimes models omit some of the available data. And on the same note as above, not every single data point is useful. And so another example of that is, let's say, and this isn't really a usefulness thing, but it will require a call out. Let's say you have an N value that's extraordinarily high. That could either mean that you have a really dense soil or really hard soil, or it could mean that you hit a boulder. And those are two very different things, right? So, data by itself is not always inherently useful or valuable. And so models kind of help us take data, convert that into helpful visualizations. Okay, so what are some common models in geotechnical engineering? I'll start off with the most controversial one. And I say controversial, nobody's out here having arguments over this over a beer, but I guess I am. And then everything else is going to be non-controversial. But PDF boring logs, I will argue that is a model. PDF fence diagrams, probably less controversial. It's kind of a model. CAD boring logs, CAD fence diagrams, models. We've got CAD models in like MicroStation, Civil 3D, and Open Roads, where you basically have configured the way you want to present the information or the data rather, and that's like synced up to a database. And as you update that database, your model updates automatically. So those could be 2D or 3D models in CAD. Then we have BIM and BIM IFC models. These are three-dimensional representations of the world. Currently, there's no standard for representing subsurface data like borehole logs or boring data in a BIM model. However, the folks over at Federal Highways are working on that. It's a passion of Derek Dassenbrock's for anybody who knows him. Very specific audience that I'm talking to here, and I'm excited to see where that goes soon. And then lastly, we have machine learning models. And machine learning models look very, very different from all these other models in that they're not visual representations, they're data representations. They're basically a gigantic matrix of numbers. And the thing that they have in common is that you can input some data and you output something that's different from the data, but provides relevant information. What I want to get at here, and I'll expand on this in the next slide, is that intentionally omitting or removing some underlying data from a model is okay, and that also, models are just visual representations of the data, or that's one version of it. So where am I going with this? The point I'm going to make here is that the PDF boring log is not dead. We don't need to kill it, and my prediction is that we're not going to. So even as we move toward this world of BIM models or 3D CAD models, whatever it is, we're still going to have PDF boring logs. So the misconception here is that those are going away entirely in favor of data deliverables like DIGS files. And I'm not saying this to say that DIGS files are not useful. The whole point of my presentation is going to be that, in fact, we need the data and we need DIGS files in order to keep this world of developing more models. However, I'm trying to kind of reduce the scariness factor. I want people to understand that we can have a world where we generate DIGS files, we generate all sorts of deliverables, and PDFs are just one of those many. And kind of the analogy I'd use to prove that is, or at least to support that, is that in 276 BC, I think, I don't know, I Wikipedia'd this, we invented the 2D map. In 1492, allegedly, we invented the 3D globe. So why in 2024 do we still have 2D maps? It's because it's a useful model. Just because we have 3 dimensions, just because we have additional, more complex ways of visualizing data, doesn't mean that the older and simpler ways are any less useful. And some simple day-to-day examples of that, we can't stick a BIM model into a PDF report. We send PDF reports around a ton. We're going to be sending PDF reports around because you can print them out. That's a valuable thing. And so those 2D representations are still valuable. They're valuable in different ways, but they're still valuable. So even as we're generating these new additional data-driven deliverables, we will still have these PDF boring logs. Okay, and just to take another kind of analogy, from a space that's already kind of gone through this transformation. What if there are no KMZs, there are no shapefiles, there's no such thing as geolocated data? We've already solved this problem in terms of geolocating. So in the same way that geotechnical models preceded geotechnical databases, geospatial models also preceded geospatial databases. So we have geospatial models, maps, globes. We talked about that a second ago. If we didn't actually store the underlying data, so we have a latitude, a longitude, and some value of what's at that location, then going from a map to a globe would be extraordinarily difficult, right? And I'm oversimplifying here. But you'd basically need to redraw your map every single time you're generating a globe or vice versa. However, because we have data interchange standards in the geospatial world, we can export a KMZ, or we can export a shapefile, or we can export a GeoJSON. These are file types that lots of pieces of software recognize, and then we can import them into other pieces of software and get those same locations. So, fast forwarding a little bit, what I'm going to get to is, what if we could do this with geotechnical data? What if you could say, I'm going to export my geotechnical data from one platform and import it into another one and know that it's going to pull the data in that I need? Again, we currently can already do this in the geospatial world. We can already export a set of points and some associated data in a KMZ or in a GeoJSON in a shapefile, and then we can import that in another platform. All we want to do now is say, well, why can't we do that with sample data, sample type, load counts, and value? Why can't we do that with lithological descriptions? What's my soil type? What's my USCS? There's enough common denominator that we can create these standard exports or these standard interchange standards and be able to accomplish what we have in geospatial with geotechnical. There are many ways to do this. The second way, instead of exporting a file and importing a file, is with an API. And so I know API is probably a word that everyone on this call has heard, but I would also wager at least 50% of the people on the call don't fully understand what it is. And the very simple explanation for an API is that humans need to download files and then upload files when we are moving data around. But what if we wanted to kind of remove that intermediary and just have the two platforms talk to each other? So an API is just a specification where one platform says, hey, if you're going to talk to me, I need you to give me the data in this format. And then you can hit that API and then it receives the message. So APIs are just the same thing as export and import, except we can kind of skip that intermediate process and have the computers or the software programs talk to each other directly. And so that's how, if you use a piece of software which has a map in it, it's probably using the Google Maps or the ArcGIS API. It's saying, hey, the piece of software calls, it sends a message to Google Maps and it says, hey, I need information about this region. Can you send me what the map looks like there? Google Maps says, okay, I'm going to charge you a few pennies, but that's fine. And then I'll send that information back to you. And then that piece of software can render that section of the map, which Google Maps sent it. So again, we already have data interchange for location information, right? And we have that through file transfer with shapefiles, KMZs, GeoJSON. We have that through direct API connection, Google Maps API, ArcGIS API. Okay, now what if we could do this in the world of geotechnical data? What does that look like? So even though the boring log's not dead, we are moving toward a world where we have more options than just the PDF boring log, right? We'll be able to have three-dimensional models, whether they're in CAD or whether they're in BIM or whatever it might be. And so, in the 80s, we've had, GINT-generated or computer-generated boring logs. In 2023, I guess we can now strap on some big piece of computer to our face and visualize stuff in the world, and there's all sorts of crazy stuff we can do, but we're still going to have boring logs because not all of us are going to strap this thing onto our face, and not every project really calls for that, right? If it's a really simple project, there's a wide range of complexity and what things call for. The vast majority of projects today, it's still not worth it to use that. Maybe it will be down the road, but at this point it's not. If we're going to be moving to this world with all these model-based deliverables, it's not feasible for us to regenerate this data set for every single type of model we want to create, right? If we had to create a new data set for a PDF log, and then a new data set for our CAD model, and then a third data set for our BIM model, and a fourth data set for the, whatever the heck we're going to be doing with these virtual reality things, that's too much work. It's just not feasible. And the other problem with that is that if you make a tweak to one of those data sets, you then have to make a tweak to all those other data sets. It's not maintainable. So how do we solve this problem? Well, we have a single source of truth database, which stores what is the actual data that we should be building all of our models off of. And then we can transfer that data really easily to these other platforms. And just like there is for geospatial data, there's going to be two different ways to do that for geotechnical data. One is by downloading a file and uploading a file, and that's where digs would come into play. And then two is through an API. And you can actually use the digs interchange standard through an API as well, but maybe that's getting too complex for this conversation. If you have a question about that, ask in the chat. But the basic premise is we can either download a file from our single source of truth database and upload it into all these other platforms, or we can have a direct database connection where all these other platforms get the most up-to-date data as we're generating it and updating it. We'll get into all this stuff in a little bit more detail. Okay, So all this stuff might sound like it's way off in the future, or maybe it sounds like it's coming up tomorrow and it sounds really scary or whatever it might be. So the next few slides here, or I guess 1, 2, 3, 4, 5, 6, 7, 8 slides, are going to go through what can we actually do with software today. And excuse me, a lot of this is based on BoreDM's capabilities, but there are other platforms out there which can do the same things, some better than others, and so forth. But I'm going to go through what can we actually do today and what's easy to do. So first of all, yes, we can generate PDF boring logs and fence diagrams. I think we all agree on that. Here's a screenshot of what that past tense looked like in like a month and a half ago on BoreDM. We've actually updated the interface a bit, but that's neither here nor there. You can enter your data on these various tables just like you had in GINT for a long time or whatever platform you used, and you get a live updated PDF there. Same thing with cross sections. You can draw a line, get a cross section. This happens to be a PDF cross section. You can download it to DXF. At the end of the day, it's line work, and that kind of brings us into our second option here, which is generating 2D or 3D exports in the CAD software, which are quote unquote dumb. And what I mean by that is we are not exporting any underlying data. All we're doing is exporting lines, lines and text with coordinates on a piece of paper. And the issue with that is that if you end up updating your single source of truth data, and then you want that to update again in your model, it's not going to be able to understand that at all because it doesn't have access to any of the data. All it has access to is I should draw a box on this part of the screen, and I should put a little pattern inside that box. So these are quote unquote dumb exports. They're still really common and still very useful for a lot of workflows today, and we'll see how long that lasts. Hopefully, the third bullet point ends up being what people move to on that front in a second, but that's the second one that we can do easily with software today. And here's what that looks like. So I'm too cheap to actually buy a CAD subscription. I think I actually have bought one since this, but that's beside the point. So I was using this free viewer. I exported this CAD cross section from BoreDM, and great, it's a bunch of lines. You can replace the hatch patterns if you want to, but at the end of the day, it's not data. It's just line work. Okay, we can also generate smart exports in the CAD software. So this is in any CAD software that accepts them, rather. So this could be via DIGS, it could be via AGS, or it could be via a documented standard. So what do I mean by this? I guess I can kind of come down to here. So in BoreDM, for example, you can have a project where you've logged a bunch of boreholes, and then let's say you want to pull your data into a CAD environment. One option you have is Civil 3D. So Civil 3D has specified a data structure that it's able to import for geotechnical data, and that's inside its Civil 3D geotechnical module. And so we have an export type which says, okay, we've got this data. We're going to format it according to the tables and the field names, or the column names that it needs, and it basically just generates an Excel sheet with that data. So that's one option. Another option is the same exact thing, but for Leapfrog. So Leapfrog has a specified data import standard. We've generated an export for that. You can take your project data, click a button, and export it into a file, which can then be imported into Leapfrog. Same thing with Surfer. Okay, and then we have these two different ones at the bottom called DIGS and AGS. So what are these things? These are very important. DIGS and AGS are essentially they're very similar to the first three things I mentioned, where it's like, hey, I'm expecting data in a certain format. Please give it to me in that format, and then I can read it, no problem. However, the great thing about these two standards is that they're not specific to Civil 3D. They're not specific to Leapfrog. They're not specific to Surfer. They work for anybody who's using them because we all agree to use the same standard. And so, as Alan was saying in the introduction, we're starting to see more traction in the space of people, with the software companies adopting DIGS and saying, yeah, if you give me a DIGS file, I can read that into my analysis tool. I can read that into my laboratory testing tool. I can read that into whatever other part of the workflow you want to read it into. And that way, you don't need to have 3 different export types for 3 different pieces of software. You have one export type, and then you can pull that into whatever software you want. AGS is the same thing as DIGS, but uses a different standard, obviously. It's been around since the 90s, and it's used pretty much everywhere except the US. But we do things better than the rest of the world, so DIGS must be better than AGS. And yes, of course, we are number one. So anyway, we have DIGS support, we have AGS support. You can export and import both of those file types. And because we know what the standard is, that works. Now, this is still considered, it's considered a smart export because we're actually exporting the underlying data. We're not exporting line work. We're not exporting draw a box on this part of the screen without really understanding what that box is. We're exporting, we have a lean clay from 0 to 4 feet, and then whatever software that's importing that data can choose what to do with that information. So that's why it's called a smart export. But it's still going to require you each time you want to update your data. Let's say you got new lab testing data and you change your classification. If you then want to update your data in an analysis tool, you have to re-export that file and re-import it in to get the latest changes. Okay, that leads us into APIs. So again, this is something that we can currently do today, is utilize APIs to pull data directly into CAD software or any other software, GIS, whatever it might be, analysis. And so what this means is that instead of having to do a download and then the upload, and again, I remind you, we can send DIGS data over an API or AGS data over an API. So these are not mutually exclusive. But rather than having to download and then upload, you can just send that data directly through an API connection where the software programs talk directly to each other. What that means is that you have the possibility to set it up where if I change my classification from a lean clay to a fat clay, then instantaneously I can hit refresh, or we can have some regular refresh rate. My CAD software knows to update that. It doesn't need to redraw the whole model. It just knows, oh, I need to switch that little part of that piece of the model or the analysis tool, whatever it might be. So that's kind of the holy grail in a lot of ways. We are currently in the works. We're building a direct connection to Civil 3D where you can log into BoreDM from Civil 3D, access your projects, hit import, and then sync that data up. So even if you build a model and then you decide, oh, we have to change the actual data, it'll pull up that updated data into your existing model. Next up, we'll work on the MicroStation one as well. That'll be a fun adventure. Okay, and here's, okay, don't get too scared by this if you're not used to seeing API data, but basically this is all it looks like. It looks a lot like a URL that you would type into your browser, but you can type in, hey, I want to get all my projects. So here's the API for BoreDM to get your list of projects, and then you put in your request options to get some specific stuff. Here's what the computer gets back. So when you run those things, it'll say, okay, well, here's our location, and within the location we have an address. We also have a latitude and a longitude. And so that's how the computers talk to each other. Okay, tools for 3D visualization. So this one is going to be a quick live demo. I'm actually going to, so I've given this presentation 2 times before, but we have some new content here. And this is the new content part. Since I last gave this presentation, we rolled out a tool, very early access tool. You can only access it if you know where to find it, but it allows you to upload PDF boring logs, and it uses AI to extract data from those boring logs and put them into BoreDM's data structure. So you could have a boring log from the 1980s, or you could have a handwritten log. You don't need to draw squares around anything or teach it where to look for stuff. It'll figure that out, extract the data, and put it into BoreDM's data structure, and then you can ask it to, you can then review that data, and once you're happy with it, you can integrate it into your database. I'll be the first to tell you, there's a lot of work that needs to be done in terms of accuracy. We're working around the clock on that right now. We have a huge project coming up that we're using it for, and so we're really excited about some of the rapid updates that we've been able to make to it. But I am going to kind of give you a preview of what it looks like. And the really exciting workflow to me here is that we can take PDF boring logs from, let's say, the 1980s. We can pull those in using AI, and then we can create a 3D visualization of those boring logs within, with this whole process happening within 5 minutes. So we can go from 80s boring log to 3D visualization in 5 minutes, to DIGS file, and then from DIGS file into some other software, into CAD model or into BIM model, whatever it might be. So this kind of, to me, really closes the loop that we've been trying to close for a really long time in this space. And yeah, I'll go ahead and demo it. So I'm gonna cheat a little bit. And I'll show you what the interface looks like. I'm not actually going to go through the digitization process because it's early and there's some stuff that we need to clean up first. But I'll show you what it looks like, and then I'll show you basically what you can then do with that data. And part of that is the 3D visualization, which was on that slide. So first of all, here's kind of the upload screen. So you can drop a file, and I guess I'll drop a file in because why not? So let me grab one from here. And what do we have here? Okay, so I've got a sample BoreDM log. I dropped in a PDF, and I can say upload files. Then I can say, so I'll say GI demo. I'll select my token bank of Yem. Yem is my puppy. And I can use those tokens to import that PDF log. I can now go to review. And so if I'm in this review view, you can see we have pending logs. So these are ones that have been uploaded and are awaiting review. We have complete logs. So these have been imported into our database. And then we have in-flight logs. And in-flight means that it's being actively processed. You can see I presented at a workshop last week. That was the same day we released the tool. So there was a big, let's see how this goes. And actually, this one already processed in 26 seconds. So we can take a quick look. So it says from 0 to 4, we have GC, and it's a clay gravel. Looks right to me. And then soil consistency. So you can see consistency should not be damp. That should be our moisture. And then clay plasticity says low to medium plasticity. Okay, so that's correct. Whoops, didn't mean to exit out there. And do we have anything else in here? No. Okay, so it should have pulled. I mean, a really obvious one, for example, is brown. So it should have pulled the color. I'm not going to go through all these. You can kind of see it did a decent but not perfect job. We can take a quick look at the samples. So it says we have an SPT at 5 feet. It's called sample 1. It thinks that my driven length is 5, not quite. And it doesn't seem to have pulled in my blow count, which should be the easiest part. So work to do, but that's basically how it works. That's about as honest of a demo of that I could give you. However, I did import some data from an Idaho DOT log last week. And basically, I went through and corrected all this data for this PDF. And here is the outcome from that. So here it is. Has a few different logs. I made sure that the location data was set properly. And what I'm going to do here is just say 3D. So, well, I guess we could take a look at one of these logs. Let's see. Yeah, so here's what the log looks like. It's got some somewhat sparse data, but data nonetheless. And now I can hit 3D. And so what this is going to do is pull in topography data from an API. It takes a few seconds because it's a massive amount of data, or not massive, but it's a lot of data. And as you can see, this tool's in beta. We haven't quite optimized the loading time yet, but we'll get there. But what it's going to do is pull in that topography data, give you a general sense of what this site looks like. Let me just scroll over here, and you can see kind of around the edges, there's a hill there that the road is kind of curving through. I'm going to change this to dark mode. I'm going to exaggerate the scale of the logs so they're a little bit easier to see. And I'm going to also decrease the opacity a little bit. If I scroll out now, we can see this project. Oh no, there's the reload. All right, so we'll give it another 15 seconds to reload again. Sometimes this kind of beta feature does that. But anyway, that's the gist of that. So again, we just took some PDF logs, which were historical data and had not previously been in the database at all. And we were able to visualize the project in 3D. I can kind of zoom in here and hover over this and it says, okay, it's silt. This is ML. SPSM, and we can also change what we're viewing by. So this is currently colored by USCS. We could color by rock type and soil type or by stratigraphic unit if you assigned them. We didn't assign any in this case, but that's how that works. So again, this is a tool that's available today. It's not like a futuristic thing. I've got a project. I want to visualize it in 3D. I can do that in 10 seconds without any additional work. Okay, let me reshare the presentation here. And then I promise I'll stop yapping soon. I'm almost done. Okay, next thing is running custom data analysis and creating custom databases using plain English, or data sets using plain English. So I do have some screenshots here, but I'm unable to resist the live demo. So I'm going to do a live demo of this in a second as well. You can basically write queries within the interface. And I know a lot of the folks on this call are not used to writing queries. Don't worry, that's the whole point of the query builder. We'll get there in a second. And then it outputs the data below, and you can download that to Excel, or you can do data visualization within the browser. So this is your LL versus your PI for all 753 rows here that we pulled, which contain Atterberg data. It's not a report-ready chart, but it's pretty incredible that you can query your entire database and get that data in about 10 seconds. So let me demo that as well. And then we're down to our last slide, and then we'll pause for questions. So let's go here. And by the way, if you guys have questions, feel free to start dropping them in the chat, and we'll get those queued up as we go. So next thing is the analysis. So I can go to this analysis tab. I can generate a query, and I know that I have in here a North Carolina DOT GINT file, which I imported a while back. And so what I'm going to do is say, it has like 618 logs or something. So I'm going to say, pull all the rows on my sample table, let's say on the sample table for the project called I-5719. So that's the NCDOT project. I want blows 1, 2, 3, 4, start depth, and let's just say in start depth. So we'll just get our blow counts. Okay, so it's generated this query for me. I'm going to run it. If it doesn't work, I came prepared. Okay. It provides the query in two different forms. So in this case, there's some tweaking that needs to be done. Sometimes the AI generates this form. It's okay. I have a saved query for the same thing. It's called get blow counts and blows 2 plus blows 3. And so what this does is it queries start depth, blows 1, 2, 3, 4, and it pulls blows 2 plus blows 3 as kind of a general n value. That's not always the case if you have refusal in the first blow count, but that's okay. And it filters for where the project is called I-5719. So I can now run that, and I'm going to get 4,600 rows for this project. So 618 logs. That's about 7.5 samples per log. I can now click visualize, and I can say on the x-axis I want to do start depth. On the y-axis I want to do n value, which is just blows 2 plus blows 3 here. And then I can change this to a scatter plot. And now I've visualized for all 618 logs depth versus n value. So this is depth here. And this is more accurately blows 2 plus blows 3. The DOT file didn't actually have n value, which is why we have to add those up. So plopped. Anyway, this is the kind of stuff that gets me very excited as a data nerd, that you can now run these kinds of queries. We could actually get rid of this restriction and say we want every sample in our database. I think it's going to limit us to 10,000 here, but we can still do that. And you'll see this load for a second. And now we've got 10,000 rows with all of our blow counts in our entire database. And I think if I visualize that, yeah, you can see most are kind of around here at, looks like 3, but then we have tons going up to 50. Okay. Enough of that. Very last thing I'm going to do is just talk a little bit about AI models and what they can mean for the space, and then I will turn it over for questions. So again, if you have questions, feel free to drop those in the chat so that we can jump right in when I finish here. So this slide says, run ML models which accelerate engineering workflows. So there's a few different ways we can use AI or machine learning, artificial intelligence, machine learning, whatever, in our space. One is as tools. So, sorry, like little workflow tools. So one example of a workflow tool is what I did earlier, where I said, write a query for me that does X, Y, Z. And so the AI model knows what the data structure, what our database's structure looks like. Oh gosh, getting a phone call. Let me, sorry, I turned off my notifications, but this one has slipped through somehow. Okay, I don't know how to stop that, so I'm gonna keep going. We'll let it ring. Sorry guys, human moment here.
Nice live demo.
Yeah. I think it's just going to ring forever and ever. Let me see if I can do this from here. This is pretty awesome. Okay, so it says that somebody left me a voicemail, but it's just choosing to continue to ring here. Give me 2 seconds I'm going to mute myself and see if I can figure this out. Still ringing. Sorry, guys. All right, sorry about that, guys.
Okay, good.
That was pretty awesome. That has never happened to me before. New stuff. Okay, anyway, I'll wrap up my talk here. So yeah, there are AI tools and ML tools. One of them is an example of what I went through a minute ago, which is like, okay, I taught the AI what my database structure is. It can write a query for me. It doesn't actually have access to any of the data. It's not running any sort of analysis. All it's doing is writing a query, which I can then run in my SQL interface. So that's one type of way we can use AI. Another is to import data. So for example, we have PDF boring logs. We want to say this is unstructured data. Let's structure it. Let's put it into BoreDM's data structure. AI is capable of doing that as well and is getting better at that really, really, really fast. In that case, the AI does have visibility into your data, but the kind of analysis it's doing is, this is a PDF of unstructured things. Let me structure it in a certain way. It's not actually trying to come to any sort of insights or come up with anything new. All it's trying to do is say, here's something that exists. Let's put it in a different format. Then the third approach is where we actually are doing analysis. And so one example that we've seen in the space is let's feed boring log data to this model and have it design foundations for a certain specific project type for us. So whether that's an electricity pole or some other type of structure, we can train it and say, here's the design that we gave or that we generated based on boring data in the past. Let's give it a bunch of this kind of data and then ask it to use that to come up with a design for things going forward. And so we've seen this already in some places, and we've seen where it can help reduce over-design. It can give you an 80% design or something like that instantaneously, and then you can have expert humans go in and kind of do that last 20%. But there's some really, really awesome things. I really do believe that parts of this space will be a matter of who can manage their data the best, such that they can utilize it with these tools. In however many years it's going to take, there will be a point at which getting data into the right structure to utilize these models becomes super critical, and that's what we want to kind of help our users do, is make sure that without thinking about it too much, you just go about your day-to-day work, and you want to generate deliverables, you want to generate whatever it is, you can generate more and more deliverables in BoreDM, but your data is always in the same structure, and that enables you to kind of leverage those models down the line. So anyway, happy to answer any questions on any of that. Sorry again about the phone interruption there. But yeah, happy to answer any questions, and I'll turn it over to the question list.
Great. Louis, thanks. This is a great presentation. I really like how you kind of wrapped everything into this model-based deliverables and really brought out the point of the difference between what I've always called information versus data and the value of having that single point of truth. So that's very useful. I thought it was interesting that you talked about having these models created or whatever, and that you may not justify doing these 3D models for small projects. I wonder what your thoughts are, and as these tools become better, are we going to just really get to the point where this is the standard and we're relating even small projects to regional geologic things and really trying to start visualizing the geomorphology or how things got to where they are to be better at what we do?
Yeah, very good question. I think probably. I demonstrated that 3D visualization tool that we have in BoreDM, and that's something where any user can take any project and hit 3D, and you get a 3D visualization. And so that's a great example of like, well, hey, if it turns out that it's zero work to do this now, maybe we should start doing it. The visualization that we're creating there is very simplistic, and you're not going to be using it for any sort of analysis or to do any sort of serious takeaways in its current form. But the point is, probably that was something that a year ago or 2 years ago, people would have said, whoa, that's a lot of work to generate a 3D model. I don't want to do that. Or maybe 5 years ago, let's say. But now it's something that can be easily done. So I definitely think that absolutely as more and more data structures can be standardized, or data interchange formats can be standardized, we can start to bring in more data sources and build more complex models with less work. The key is always going to be, can we agree to store our data in a standard way? And it doesn't need to be the database that's the same for everybody, because that's the whole point of DIGS. Is it's an interchange format. It's not a database structure. It's an interchange format. So two different people can have two different database structures and still interchange that data. That's fine. However, I would make the case that within an organization, there should be a really strong movement to standardize. And that way, when you build internal tools or when you build systems that kind of talk to each other internally, those things don't need a bunch of interchange files all the time. They can just pull from the same data structure. So if you want to pull from the USGS and get information about the geology nearby, yeah, there's an interchange structure that can pull that in. But once you pull that in, bring it into your database, which is standardized, and then utilize your internal tools. Anyway, I've gone a little bit off topic, but short answer, yes, I think so.
Very good. Hey, your question, your discussion about PDF conversions, that's coming from all different directions these days, and everybody's got tons of that data. A little curious about your experiences with limitations that you've found. Where are the real sticking points in making these tools work? And really, is it just a horsepower hog? We just need more and more computing power to be able to do this efficiently, or is this something we're gonna make work simply?
Yeah. So I've been in the weeds with this a lot over the past couple of weeks. The challenge with boring logs is not specific to boring logs. It's more of a visual data problem, because a lot of large language models are trained to ingest text and then make predictions based on text. They're not as well trained on visual data, and there does not exist a lot of labeled boring log data out there. So it's not like we just need to find all the labeled logs and put them into the model, and eventually the model's going to get good enough. We either need to create synthetic data, so we need to create an automated pipeline to say, I'm going to create a fake boring log and I'm going to provide you the data that I used to create that, and therefore that's going to help train the model. Or we need to improve the technology that reads from PDFs. I think that we're actually in a place, I think BoreDM particularly is in a place where we're capable of doing both. As of last week, we've made a lot of progress in really, really recent times. And so we're making really serious progress on both of those fronts. The model that you guys saw today was better than the one that I presented last week. And the model that I'm going to present literally tomorrow, not on such a big platform, but to a small group, is going to be a lot better than the one that I presented today, because we made some tweaks to the model and we're going to retrain it. So I think it's less about computing power, and it's more about making tweaks to how we understand visual data, and then also making sure that we're generating a lot of training data specific to our industry. The last thing I'll say on that is oh gosh, I had one more point. Maybe I'm forgetting what it was. If it comes back to me, I'll bring it up. But I remember what it was. The last thing I'll say is things are moving really, really fast in the world of AI. And it's not just reading PDFs. There are other parts of the geotechnical workflow which I think are going to be impacted by AI in a really positive way. I won't get into them right now, but I'm really excited about it. I think to a certain extent, there are people who are going to benefit and who are well positioned to be the early adopters and should and work with us. And there are really great reasons to do it now. There are also good reasons, especially if you're a smaller group, to wait 6 months and see, what does this technology look like in 6 months? What does it look like in 12 months? The rate of improvement is just outrageous. So the bigger, more well-resourced organizations should embrace this as fast as possible, because you have enough data at scale to start making a difference today. Smaller ones, maybe wait and see.
It's amazing in the geotech world. Traditionally our software development or evolutions are measured in years, and now we're talking about months, and it's really happening. I did get a question from Chet's engineers that they want to know kind of what's different in BoreDM than other softwares. What are you doing better or different than your competitors?
Okay, yeah, I appreciate that question. Where to start? So I think
top three.
I think a few things. So one thing which might seem obvious or not that important, but it actually is extraordinarily important, is modern interfaces and ease of use. So we are a company which is almost entirely software developers who have experience building software. And I think for a long time, this industry has been somewhat plagued by software built by people who are not software developers. And therefore, you end up with tools that maybe calculate things nicely or whatever, but they're really, really difficult to use. And that's not just a problem because it takes training time or whatever. It's a problem because people just don't use software that's hard to use. You'll struggle to get adoption, and people also start to build workarounds to doing things the right way in the software. They'll do things that are faster and easier for them, and that don't store data the right way. And so that's what we kind of see with some other software programs is people say, oh, it takes me way too long to enter data the way I'm quote unquote supposed to in this program in order to generate a quality database. I'm just going to jam everything into this one field and I'm going to get it to do things this way because I don't have time to figure this thing out. With BoreDM, we're really, really, really thoughtful and really quite good at understanding what is the underlying geotechnical data structure that needs to happen here. So let's structure this data the right way, and then let's make it really intuitive for engineers. Thank you. Let's make it really intuitive for engineers to input data that way. So one really great example, which our competitors, I welcome you to please take this take this feature. In BoreDM, when you're entering blow counts, you can type 50/4 into the blows one field. On another software platform, that might store 50/4 double quotation marks to represent 50/4 inches. That's horrific data management, right? Because you have two different fields or two different numbers in the same field, and you have text in what should be a number field. And then you can't do things like analysis. You can't add numbers. You can't run any sort of large-scale analysis. You can't create visuals which are based on actually understanding that number. And so the way that BoreDM handles this is that behind the scenes, we're actually splitting that into two fields. We're putting 50 into one field. We're putting 4 into another field, which you don't even see. And then, of course, we're putting the slash and the double quotation mark just on the front end. That doesn't actually get stored in the database. And so, again, that's one really small example, but it makes a huge difference because if you don't let engineers type 50/4, they're going to figure out a way to type 50/4. That's what they know. And what you'll end up with is a bad database. So that's I guess, kind of two things in one. It's user interface and then also really, really understanding what should this data structure be. Not how do I finagle it to make my software product work for people, but what's the underlying data here as people who are experts in data, and then let's make it intuitive for people to enter that data. So I think that's like one really big thing. The only other thing I'd mention is because we are software developers, we move extraordinarily fast. And I know that for some people that might seem new in this space because we're used to software that just kind of is the same for really long periods of time. But that's really an old model of software development where you download a piece of software, you pay for it once, and then the company waits long enough that like you're willing to pay for a new version, and then they dump out a new piece of software which you download and use that version for a long time. It's really outdated and it has poor incentive structures in place. And so what software as a service with recurring subscription models does, and unfortunately all of our, I think everyone in the space has kind of moved to recurring subscription models, but what that kind of enables is it says, we're paying, at this regular interval. Unless you keep making this product better, we're going to stop paying you. And BoreDM makes it really easy for you to take your data and go elsewhere. You have complete ownership of your data. If you want to export it all on any given day, just hit the download button, get a giant Excel sheet with all your data or zip file, or we can give you a SQL database file, whatever it might be. You own your data. And so that puts a ton of pressure on us to make sure that we're constantly improving the product, that we're listening to our users and adding the things that matter to you. So if it weren't for that model, I don't think we'd have the incentive structure in place to go out and build monitoring while drilling tables so that our DOT clients can do that. We'd say, no, there's, a couple DOTs, whatever, our next release comes out in 3 years, we'll do whatever. But because we have this awesome incentive structure in place, we iterate extraordinarily fast. We added that, within a couple months of somebody asking for it. And so now we're able to help those DOTs collect that data. It's really awesome. There are all sorts of really cool features that we build every single week. And that kind of software team mentality and experience is kind of what sets us apart, I think.
Very cool. It's exciting. Hey, I got a question here that I'm not real sure I completely understand, but I'm going to twist it to something that works with one of my questions. The question was, can you store visuals to use with other projects? And I guess that ties into that example you did where I did the statistics on all the borings that are in my database. So if I was North Carolina DOT and I looked at all the blow counts across my state, could I use that mass visual and plot my new project on it and statistically see if it fits with what the overall trend is? Are there other statistical evaluation tools you're building into BoreDM that will help us in the future make more educated decisions about good and bad quality data?
Okay, yeah, really exciting question. I'll name drop the word LRFD because I think that's for anybody who that means things to today, like that's going to be more and more relevant. Being able to run statistical analyses really easily on your projects is going to be relevant going forward, and it's why it matters that 50/4 double quotation marks is not in one field. So that's why database management matters. If that didn't mean anything to you, forget that intro part. To answer the question, currently BoreDM is structured so that it's really easy to query your data and then use that queried data to run analyses on other pieces of software. So if you want to, say, pull your blow count data from that NCDOT file and then overlay it with data from some other source, you can export that blow count data that I was showing. There's just an export button, put it into an Excel sheet and pull it into a Python environment, or just pull it into some other Excel file, whatever it might be. So that's one option. One more kind of example of that is, I keep talking about MWD data because I'm really excited about it right now. MWD data, for those who don't know, is that it's monitoring while drilling. And basically, you can put some equipment on your drill rig, and it'll tell you what's your torque, what's your drill rate, all these various things as you're drilling. And it can plot these things on little lines that kind of look like CPT lines. It's not super useful yet because we don't have correlations. We don't have enough data that says, oh, if this value is here and this value is here, then therefore I have like a sandy clay, whatever. We just don't have enough data. Some regions do, and some studies have started to work on this, but it's very much in progress. The reason I'm so excited about it is because now that we have a place to put that data, DOTs are starting to drop that in, and then we can start to overlay it with these other things. So we can say, where we have silty sands, plot the MWD data, or whatever. You might want to create an overlaid plot. It's a little tricky to do from directly within the interface. You can do it with our visualize tool, but I would recommend just doing a data pull, like query the data, and then export it to Excel and use some other tool for that. Another great example of that is, what if I want to overlay my laboratory testing data with my MWD correlation or my CPT correlation, whatever it might be, so that I can kind of calibrate my CPT correlation. It's another thing you can do in BoreDM. Because you have all your lab data on the same platform, BoreDM has a complete laboratory testing module. You can assign tests, run the calculations, pull them back into your logs. You can compare that data because it's in the same database within the same platform. So anyway, this is the stuff that gets me really excited, but I'll pause because I know we only have 2 minutes.
Well, maybe one last question, and I'll challenge your live demonstration skill sets here. Nick Miller asked, can you show us what CPT data presentation looks like in BoreDM?
Yeah, okay, we can do a live demo. This also has a beta tag on it, but I feel confident that we can at least give you a sense of what it looks like. So
without any phone calls?
Yeah, hopefully not. I really hope not. I never get calls on that number either. It's crazy. But that was fun. Okay, so here's where you can upload your file. I know I already uploaded a file for this test project. So I've got my depth, cone resistance, friction sleeve, and pore pressure. Lots of data. You can see even with all this data, it's still very fast. There's no sort of like speed constraint. You can define your own custom correlations, mappings, and constants. Potato constant, very common constant. If we take Matt's correlation as an example, we can hit edit and say, okay, YAM's I mentioned before, YAM's the name of my puppy, so I've been using this word a lot. YAM is 33.49 over potato. Potato is that constant that we imported. Actually, that's why this correlation wasn't working earlier. I need to import potato. And then Matt's 2.3 times YAM and so forth, and great. And now I can go to charts. This is where you can kind of set up the charts. I think I need to set a default value for potato. Does that fix it? Oh, it's still not working. Okay. I don't know what's up with that correlation. Let's delete it. If it doesn't work, just delete it. So here's this, and then I'll change the scale. So maybe I'll make my x-axis range something more reasonable here. I think I can overlay another plot. Yeah, okay, cool. And then I can generate a PDF. So I'm going to do it with the legend and see if that works. Okay, magical. So there are my plots with the various things that we're plotting, and you can see it's not complete. We have null coming in for our units. That might just be because I haven't set the units. I guess we can check real quick. Output units, yeah. So whatever, PSF or whatever it might be. I guess it says over here, TSF. Point being, that's the general workflow. We're adding a bunch of new stuff here, and soon we'll take away the beta tag. But yeah, really exciting stuff here in terms of customizability. Site by site, you can set your constants and say, oh, for this project, it was actually this, or For this project, it was 9.2, but this particular log, it was something else. Very, very customizable. If there are more questions, let me know, but that's the quick one.
All right, cool. And I like the fact that you showed us to quickly program and, edit programs, codes that you need. In fact, I guess that springs into Juan's question here. He says, the example you did where the AI failed to generate a query that ran correctly, does that mean that then I have to understand the syntax to be able to program it myself, or are there other ways to kind of fix those bugs and make things work?
Yeah, good question. So I would approach this from 3 sides. 1, okay, if you understand the syntax, great, you can fix it yourself. 2, if you don't, and your company is big enough that you have like an IT group, then you can send it to your IT group and say, hey, can you help me get this query to work? They can get it to work, and then you can add it to your list of saved queries. And within Boredom, saved queries actually fall under the same concept of a resource. So as like a log template or anything else, where I can say, here are my saved queries. I can click on any of these and run them. But I can edit the share settings. I can say this team of users. So let's say the Salt Lake office, they have view access to this query, but nobody else has any access. So I can delete that. Now only people in the Salt Lake office will see this particular query in case there's a query that's regionally relevant or something. So if your company's big enough, again, you can have your IT group go in, make a set of queries that perform a set of tasks that are common for you guys, save those, share them with the appropriate group, and then go that route. If you're a small group and you don't have familiarity with this kind of syntax, I would say just reach out to our support team. So we have a support bubble down here and shoot us a message. It says we typically reply in under 30 minutes. That actually used to say we typically reply in under an hour, but it's automated. It uses like live data to tell you how quickly we respond. That is accurate. You'll hear back from us within 30 minutes. If you need help, we'll help you build that. Cool. And the next thing we'll do is build support documentation that explains to people how to create the query that you weren't able to create. So that's kind of how our iterative feedback mechanism works.
Very cool. It's nice. Like you say, you've listened to the engineers and you've got ways to respond to them. So that's great. I think that's kind of all the time we have today. So Louis, I really appreciate your effort, and I look forward to the next generation of new features you were talking about there, and look forward to that next webinar.
Awesome. Thank you, Alan. Thank you, Brad and Amber. Really appreciate everyone's time. And yeah, feel free to reach out to us. I guess I should plug how to reach us. It's let me share my screen one more time. If you want to reach us, our contact info is there. Oh, I shouldn't have put my email. Oh well. I'm gonna do a live edit here and say you should reach out to hello@boredomlogs.com. I'll respond if you email me as well. That's totally fine.
I just want to know what that phone number was so I can call you and pester you in the middle of presentations.
That is exactly the phone number that was ringing during the presentation. So yeah, if you want to get in the way of any of my presentations, call this number right here. All right, there we go. Thanks everyone so much. Appreciate it. And yeah, I don't know, Brad, if you have anything you want to append, but thanks again.
Well, I always have things to append. It's pretty basic, it's pretty quick, but I want to tell you, thank you for a great presentation today. We really appreciate you doing this. As you can probably tell, there's a high level of interest in our community in this topic, and I think you're probably going to get some follow-up questions from that. For our viewers, especially the people who ask questions today, thank you so much. The real value of these is that they are interactive, that you can show up and you can ask questions directly to the presenter and get an answer back. And so we really appreciate you being here with us. If you liked what you saw today, and I imagine that you did because you're here with us at the end, of course, click like, subscribe, and get notifications. And yes, if you do those things, we will let you know every time we post something to the YouTube channel. Louis, Matt, thank you. Well, thank you for existing, and then thank you for doing the presentation today. This was fantastic. Alan, thanks for moderating from down there in Southwest Virginia, where you find yourself, and great job, everybody. And I don't know, that was my thank you. So again, for all the viewers, tomorrow is our next live stream. It will be at 2 p.m. tomorrow afternoon, and it is, of course, Terzaghi Day, where we celebrate the birth, the life, and legacy of Carl Terzaghi, the father or grandfather, as you want to call it, of soil mechanics. Carl is with me here. We will have Sebastian Lobo Guerrero from our Pittsburgh chapter, who is in the employ of American Geotechnical and Environmental Services, Inc. He will be our Terzaghi Day speaker tomorrow, talking a little bit about Carl Terzaghi and then about how his career influenced Sebastian's work. And then we'll have a little Q&A at the end. So you want to be around for that. Amber Davis was our producer today. Thanks again, everybody, for watching, and we will see you all soon.